Okay, let's look at rational functions, right? So rational function f of x is simply a polynomial function on top, so it's a p of x, over another polynomial function q of x, right? So polynomial function over polynomial function is called the rational function, right? And if you want to find the domain of this rational function, and the domain is going to be, maybe I'll go here, domain is all real numbers where the denominator, so q of x, is not equal to 0. All right? So let's look at a couple of examples. Right? First example, right? F of x is equal to x over x minus 2. Right? X is a linear function and also a polynomial function of degree 1. And also the denominator is a linear function, so the polynomial function of degree 1. Right? So polynomial function divided by polynomial function. So this is a rational function. Right? So if you want to find the domain, you see that we don't want the denominator to be 0. So when x equals 2, it becomes 0. So the domain is going to be all real numbers except 2. Right? So maybe I should write that. So domain D is going to be all real numbers except for 2. So I'm going to use interval notation. So it's going to be negative infinity all the way to 2. Right? Not including 2. All right? Then starting back up, not including 2, but all the way to positive infinity. So that would be the domain of this rational function. All right, and a couple more terminology. You can see that if you look at the graph of this function x over x minus 2, the graph is shooting up this way and it's shooting down coming from the right. So that vertical line right here at 2 is called the vertical asymptote. So this guy right here is called the vertical asymptote. Right, vertical asymptote, and in this case vertical asymptote, so vertical asymptote, right? It's a vertical line. The equation is x equals 2, so this is x equals 2. All right, so let's look at the horizontal asymptote. So horizontal asymptote. Right, so you can see that here, the horizontal line right here, so that's going to be y is equal to 1, right? So this guy right here, so maybe I'll write here, it's called the horizontal asymptote. Asymptote. Right, asymptote. All right. Let's look at the next example, second example. G of x is 4. 4 is a constant function, which is, you can think of it as a polynomial function of degree 0 over x squared minus 4. All right, so graph looks like this. All right, so you can see that the problem is when x equals either negative 2, all right, so maybe I should negative 2 or positive 2, will make the denominator equal to 0. So the domain for this rational function is going to be all real numbers except for plus or minus 2. So we can go from negative infinity to negative 2, skip negative 2, then go all the way to positive 2, and skip positive 2, then go all the way to positive infinity, right? So that would be the domain. right? Then the vertical asymptote, in this case from the picture, there are actually two of them. Vertical asymptotes, right? And first one is x equals, right, this vertical line right here, x equals -2, right? Second vertical asymptote is x equals +2, right? And the horizontal asymptote is going to be, right? Looks like this x-axis, the horizontal asymptote, is getting closer to that horizontal asymptote here and there. So x-axis has equation y equals 0. All right, so that's the horizontal asymptote. All right, but anyway, so rational function is a function where you have a polynomial function on top and another polynomial function on the bottom. All right, that's it. I hope that this was clear.